Evet, 2020-2021 güz yarı yılı Numerical Methods 2. öğretim A şubesi 20 Ekim saat 17 dersidir. Ben Hasan Serhan Yavuz. Şu anda ders kaydını başlatmış bulunuyorum. Alright, last week we talked about that. This week we will mention how to use M files, how to use GNU Octave or MATLAB. Today we can continue. One of your students states that my sound looks not very good. Are you so? Will you please send me some feedback, please? In today's morning class, there was no problem. I'm using the same computer. I'm using everything as the same. Is there any problem with my sound?
No, it's fine.
It's fine, you say? Okay, thank you. Now, as I stated, today I will talk about M files. M files are a special file format of MATLAB indeed, but as I stated before, MATLAB is a licensed product. As an alternative, GNU Octave, we can use GNU Octave. Also, the same M files can be executed in GNU Octave platform as well. Let's introduce MATLAB first, and let me introduce you GNU Octave I will introduce both MATLAB and GNU Octave comparatively, by the way. Let's start with MATLAB. MATLAB uses three primary windows: command window, graphic window, and edit window. Command window is used to enter commands and data. Graphics window used to display plots, and graphics edit windows used to create and edit M files. Let me show you how they work. Let me just run MATLAB in my computer. This here. If I run MATLAB, you will see some kind of visual things that I will describe. By the way, I can just adjust the Epic Pen at the same time. Okay, it is open. Here, this part is the command window of MATLAB. It is written, the name command window is given in there. It means that we can write any individual commands here. We can use command window basically as a calculator. For example, 23 times 15, let's say an arbitrary calculation, okay? We can directly write numbers and mathematical operation here, and MATLAB automatically gives the answer to you. And you can see it in the command window. In the command window, at the same time, we can only enter only one command. So it is a kind of thing that if you have only one command of calculation, you can feel comfortable to use it. The second one is set as the graphic window. Let me clear the screen first. Graphic window is the figure window indeed. Here, if I write figure, MATLAB automatically opens a figure, and we can make a plot of a function. We can visualize some data here, or we can use that window also as a programming tool as well. We can just show here some images. We can put some push buttons and entrance objects as well, but it's a more advanced programming stuff of the MATLAB, and in this class we won't use it. Okay, I'm just informing you that you can also make visual programming here by using the figure window, but this is not our subject. We will use figure window only for function plotting. We will use command window and the editor mostly, and the editor is the edit window. You can click here to open the editor, or you can write the command edit as I have written here. Okay, if you write edit and hit enter, it automatically opens the editor. It is written there. Editor, as you may guess, we can write multiple commands here in this area. We can write anything we want. Of course, I'm just arbitrarily writing something, but they are supposed to be MATLAB commands, and we can save this file to our working folder, and the file extension will be .m. That's why I call today's lecture name as the M files. Let's see GNU Octave. If you install GNU Octave, you will see two types of GNU Octave here. The first one, in parentheses, there is a word CLI, stands for the client. The second one, GUI, stands for the graphical user interface. If you just run the client version, an old version, like MS-DOS prompt window opens, and I don't prefer to use that one. You can also use this case as the calculator. You may just find out calculations, but I don't like that screen. That's why I recommend you to use the graphic editor one, okay? GUI one. You can double click and open the code. As you see, a similar screen to MATLAB arises, and there also exists command window here. This is the command window part of GNU Octave, as in MATLAB. It is used for the same operation, of course. It is written command window here. Again, you may write any calculation here. Let me arbitrarily write some numbers and multiply them. We can see the answer here. Okay, this is the command window. The editor window of GNU Octave just arises here in the new tab. If we click the tab, it becomes the editor, and here you can write again multiple commands, whatever you want to write. These will be the MATLAB commands, and after you may hit save file and run button. In MATLAB, also in the editor MATLAB, there is a run button here. If you hit there after writing your proper commands and scripts, the file automatically runs. Let's continue. As I stated, the primary usage of command window, and I call it as the calculator mode, can be used as a calculator where you can type in commands line by line. Whenever a calculation is performed, MATLAB will assign the result to the built-in variable answer. What is this? Again, we made a calculation in MATLAB screen there. Remember, 23 times 15 was equal to 345, and MATLAB automatically gave ANS. It is the name of the variable in the memory. If I write the name and hit enter, it automatically shows me the its value, whatever it is. The same thing is valid in GNU Octave as well. Let me just, by the way, can you see my screen, my computer?
Yes.
Okay, there is no problem. Thank you. Also here, this is the workspace of GNU Octave, and this part is the workspace, and we can see the defined variables here, ANS, and this operation was another multiplication. The answer was that one. Also, GNU Octave does the same thing. If we don't make any assignment, if we just calculate something, they automatically show us the result in a variable which is named ans. But here, if I make another operation, let's say 3 times 2, basic operation, ans is now 6. It can only store only one arbitrary variable, ans, both MATLAB and GNU Octave, and the last operation is stored. If we want not to lose the value, what we can do, we can make assignments here. let's say a equals to 3 by 2, a equals to 6 now. You can also check it from the workspace as I stated. We may say b equals to a times 15. Whatever a, okay, we can automatically call another variable in the operation. It is easy. We don't need to predefine the variables first. For example, double or floating point number or integer. MATLAB automatically does this one for us. We can just write directly the operation or directly make the assignment. Let's say c equals to 35. We can make that types of assignments as well. Now a, b, and c are stored in the memory. If I not restore a new value instead of them, they are kept. Here, if I make again another arbitrary operation, only ends changes because this is a variable that automatically created for no assignment cases. For my assignments, they are not cleared. Until where? Until I use the clear command. The clear command clears the memory. When I hit enter, maybe you can check it there by looking at this rectangle inside this rectangle. When I hit enter, everything will be cleared. I'm hitting enter now. As you see, everything is cleared. There is no a and b in the memory now. If you hit a and b, it states that a is undefined. A similar error gives the MATLAB. There is no a defined here. If I hit a name which is not defined, it states that undefined function or variable a, because there exists only a and s in the memory. If I hit a and s, it shows me the result of it. But if I hit any other things, it states that you didn't define it yet. It is an undefined variable or function. Where is my PowerPoint? We are here. Okay, we can continue. While using the ans variable may be useful for performing quick calculation, its transient nature makes it less useful for programming. Yes, it's a handicap for programmers having only one variable. Instead, we can make assignments, and MATLAB allows us to assign values to any variable names. This results in storage of values to memory locations corresponding to the variable name. MATLAB can store individual values as well as arrays. It can store numerical data and text. MATLAB can also store both text and numerical data, vector matrix notations, which makes it advantageous to use indeed. Also, MATLAB does not require that you pre-initialize a variable. This is really important. We didn't pre-initialize it. For example, define a as integer. We didn't use any command like that. We just write the name and write an equality sign. A is equal to blah blah. It can be a mathematical operation, or it can be direct assignment. A equals to 15, for example. If it does not exist, MATLAB creates us automatically. For the assignments, equality sign is used. It is really important. If I write a equals to 4, MATLAB automatically assigns number 4 to the variable named a. Here, I have an important warning that related to variable names. Variable names must start with a letter. Has to be, okay? It's an obligation. For example, we can use A, B, C, D, or any letter in the alphabet, but we cannot use special characters or numbers at the beginning, okay? At the beginning, we have to only use some letter, and after it, we can use numbers as well, and only the underscore as special character. For example, I can define b_1, it is okay, or b1, it is okay, it is another variable. Let me show in MATLAB It will be better. Here I have the MATLAB screen. Let's write A is 23, B is 3 over A, whatever it is, okay? I can write B1 equals to A over 7. As you see, B is another variable, B1 is another variable. Also, capital letters are something different than the lowercase ones. Lowercase b is a variable, capital B is another variable, so you have to be careful when you define your variables. We can write b2 equals to 5, it is okay, but we cannot write 2b equals to 4, it gives an error, okay? This error here is because of we have started with the number. We cannot start with a number. We have to start with a letter. Also, we get the same error when we try to use special characters other than underscore. We can use underscore. There is no problem. Let's write G2 underscore 1 equal to 56. It is okay. But we cannot use something like this, okay? Let me use question mark. It gives an error because of question mark. It's a special character and I cannot use it in variable naming. So you have to be careful. Use letters, start with a letter, and after you can use numbers and underscore. You may feel comfortable that you can define many different named variables by this way. A1 equals to 2, A1 sub 1 equals to 4, for example, A1 sub 1 equals to 45. You can try yourself that you can use many definitions here. Of course, there is a limitations for naming and it depends on the version you use. Maybe you can check the internet and how long does the current version of MATLAB uses name, but it is not short. Believe in me, you can use very long namings as well. It still makes this assignment, and this is pretty enough for us, I think. And scalars. You can tell MATLAB not to report the result of a calculation by appending the semicolon. This is the semicolon symbol, by the way, to the end of the line. If we put that semicolon to here, MATLAB does not show the result to us. Let's say if I put it here, it does not show this one, but the variable still stored in the memory. Let's try it. This is my MATLAB window. Let me clear everything. CLC clears the screen, by the way. A equals to 2. Let's write. If I write direct A equals to 2, MATLAB also shows the answer in the command window, also GNU Octave. But if I put B equals to 3 and put a semicolon here, in the memory, MATLAB automatically creates B and assigns the number to it, but it does not show the result on the command window screen. If you want to show the result, don't use that semicolon. If you use it in the command window, you won't see anything, but in memory, of course, it makes the proper assignments and proper operations. This is one usage of semicolon operator. Later on, I will just talk about another usages of semicolon operators as well. Also, we can use any name, but there are some special characters in MATLAB or special variables, such as I and J. They stand for the unit imaginary number, complex number. And again, let me use MATLAB to show it. In the memory, we have only A and B. If I write I and hit enter, MATLAB automatically states that the value of I is 0 plus 1j. It is a pure imaginary unit, complex number you have seen in complex calculus. Also j. I and j are the same numbers in MATLAB. There is not a difference. As in electrical engineering, we use symbol j as the complex representation, not to confuse to current, because we usually denote the I with the current in the circuit. That's why for the complex representation we use j. MATLAB uses both I and j for complex representation. But what happens if I make any assignment, or can we make an assignment to I? The answer is yes. If you hit I equals to blah blah, you can use directly numbers, or it may be a calculation, doesn't matter. MATLAB now just replaces that complex imaginary answer with the last one, as you see here. Now, if I hit I and hit enter, what happens? The last entrance of it is 34. We forced to change it. That's why in the memory now it is I. It is kept until you make clear. If you make clear and hit I again, there is no I, as you see, and the value of I is 0 plus 1j. We gain it. So you can be careful by making naming assignments. In numerical methods class, we won't use any complex numbers, but in electromagnetics or circuit analysis classes, you mostly deal with complex numbers as well. You have to be careful for variable naming, that don't assign to I or j anything, because in this case they represent the complex imaginary number. Format command is used to specify the number format in MATLAB. Also, there are some special characters such as pi. Pi is automatically defined in the MATLAB. It knows the value of that pi constant. And if I want to see some extra digits, I have to use format long command. This format is related to number formatting, not related with hard disk formatting. Don't confuse. It is related to number formatting. If we write format long and hit pi, it shows me more precise results. And also, this number representation is related to the version of the MATLAB that you use. In this version, it shows us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 digits. What about GNU Octave? Let's check it. Format long and write pi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They are the same, okay? For these versions, of course, for some older versions, you may see less numbers as well. But anyway, this precision is pretty good enough for us in this class. There is another special formatting called short engineering. This is engineering format with at least 5 digits and a power that is multiple of 3. This is preferred for units, of course. In your calculations, if you want to explain the results in milli, micro, for example, consider the capacitance units. Capacitances are usually expressed in microfarads or even nanofarads or picofarads. If you use that type of representation, and if you use short engineering, MATLAB shows the answer. Let's try it. Format short engineering. I've forgotten one word. Okay, this is all right now. And let's calculate epsilon 0, 10 to the minus 9/36 times pi. If you remember from electromagnetics class, permittivity of free space was equal to this, and it is a very small number. It automatically expresses the result in as the exponent part. This is the exponent. This times mantissa times 10 to the minus 12 is the answer. Even if 10 times f0 we use, it still expresses the power as the multiples of 3. This is in pico range, okay? 88 blah blah. But in format short, what about ends? MATLAB in fact automatically uses one number here, puts a comma, and uses the fraction, and this is the exponent, of course. In format short representation, MATLAB uses only one number here, then it puts a comma, and the rest is expressed in the exponent representation. But if you use format short engineering, the exponent is kept with the multiples of 3. This is the only difference. In this class, we won't use short engineering. Short is enough. Maybe at most we can use format long to see more precise results as well. The same example valid in this slide. If we use format short and CPy, MATLAB automatically shows only 5 significant figures to us. If we use format long and pi, it gives a more precise result. Another advantage of MATLAB is that MATLAB can automatically handle rectangular arrays of data. One-dimensional arrays are called vectors, and two-dimensional arrays are called matrices. The name MATLAB, in fact, comes from matrix laboratory. That's why it is really easy in MATLAB to define matrices or vectors. Arrays are set of using square brackets, shown here. If we see two square brackets, we can understand that the inside there is either a vector or matrix. Vector is a kind of matrix indeed. Vector is a 1 by n or n by 1 matrix. Matrix can be any arbitrary dimension, m by n. Entries within a row are separated by spaces or commas, and rows are separated by semicolons. This is also important. This is another usage of semicolon operator. In matrix entry, semicolons are used to separate the rows. If we want to define a row-wise vector, we only need to use just space between the two entries, okay? One space is enough, but you can use more spaces as well. There is no problem. MATLAB automatically understands as a spacing between these two numbers, and it understands this is the first entry, there is a space, this is the second entry, there is a space, third entry, space, fourth, space, fifth, space, and finished. And this is a vector or a matrix of 1 by 5. This is a vector of length 5, and the elements 1, 2, 3, 4, and 5. What about if we use semicolons? As I stated, MATLAB thinks that it is a matrix entry, and line 1 is finished here, okay? Line 1, there exists only one element, 2. Line is finished. The second line element is 4. The third line, 6, 8, and 10. That's it. The difference is that the first one is called a row vector, and the second one is called a column vector. The size of the first one is 1 by 5. If you consider matrix dimensions, this is a 1 by, this has a 1 by 5 representation, and this has a 5 by 1. This is the only difference. MATLAB does not display brackets in the command window. The reader or user needs to understand it. If you are using a monospace font such as Courier, the display values should line up properly. We recommend you to use Courier, Times New Roman, or Arial, these standard fonts. Otherwise, you may feel difficulties in reading some calligraphic letters or numbers. 2D array or matrix of data is entered row by row with spaces or commas. We can use spacing or commas as well. For the MATLAB, these are equal to each other, okay? In matrix entry, of course. Space or commas, separating entries within the row, and semicolons separating the rows. Here we have an example that name of the variable is A. This is an assignment. I see a bracket here opening. It means that the entry will be a matrix entry or vector style entry. And the first row is 1, 2, 3. Row is ended now with that operator. The second row is 4, 5, 6. It's written here. Row is ended here. The third row is 7, 8, 9, and the result is 3 by 3 matrix. Okay, it is easy to enter that type of matrices in MATLAB. Let me show some example to you related to vector and matrix entries. Let's clear everything. For example, if I write A is equal to, I'm making an assignment. A is the name of the variable that I used. Memory is cleared. There is no other variable defined. If I just use that bracket, MATLAB automatically thinks that I'm about to enter a matrix or vector style entry. 1, 2, 3, 4, 5, 6, and 7, let's say. If I hit enter, it automatically stores this. And in the workspace, MATLAB shows us in table representation. If you use that type of representation, you can understand that they are double, they are numbers. They can be either a scalar, I mean only it can include only one element. It can be a vector. This is the vector, by the way. It is a 1 by 7 row vector. We can also define column-wise vectors as well, or matrix, of course. Only thing we need to do is to use that semicolons. B equals to 1, 2, 3, 4, for example. Now, the dimensions of B is now 4 by 1. And it is a column-wise vector, as you see. 4 by 1. Let's enter some matrix entry. We can write capital A equals to 1, 2, 3, 4, 5, 6, 7, 8. This is enough, I think. I can just make it close. And A is a matrix of 2 by 4 now, and you can just see and check whatever it is in A. We can just write another vector. A is a 2 by 4 matrix. Let's define a 4 by 1 vector. Let's say -1, -2, -3, -4. But in order to be 4 by 1, I have to put a semicolon after the entries. Now, A is 4 by 2, D is 4 by 1, sorry, A, D is 4 by 1, and there is a special operator, transpose operator in MATLAB that apostrophe sign takes the transpose of a matrix or vector entries. Let's check what will happen when I just use a transpose operator. Let me clear everything. Transpose operator. Remember, D was a 4x1 vector. I may write an assignment, or if I write D transpose directly, MATLAB again automatically calculates the result and makes the assignment to the answer variable, or I can just write E equals D transpose as well. Both correspond to the same thing. Now E is 1/4 now. E is 1/4. A is 2/4. D is 4/1. Okay, this is 2/4. This is 4/1. I can make matrix-wise multiplication. If the entry is a matrix, and if I make multiplication, MATLAB automatically makes the multiplication in matrix-wise. It just multiplies a 2/4 matrix. Let me write here. Okay, here A is at 2/4. I'm sorry, 2/4. A is open there. It has 2 rows, 1, 2, and 4 columns, 1, 2, 3, and 4. What about D? D was a 4/1 vector, and the matrix result of this multiplication is these 4's cancel out, 2/1. This is another vector now. And this is the answer, okay? When we use multiplication or divisions, MATLAB automatically considers it as a matrix-wise multiplication. So you should be careful here. Accessing array entries. Individual entries within an array can be both read and set using either the index of the location in the array or the row and column. The index value starts with 1 for the entry in the top left corner of an array and increases down a column. The following shows the indices for a 4-row, 3-column matrix. We have an example, and we can directly have an idea about any arbitrary elements. Let me just use MATLAB to explain this subject again. It will be better. I can use some arbitrary numbers. Doesn't matter. Let A be some matrix Z to construct and consider. I have defined a 3x3 matrix A. If I just write A here, A is the name of the variable I have defined there. And under the parentheses, if I use some numbers, the first number indicates the row number, the second number indicates the column number. Okay, if I write A2, 3 and hit enter, it automatically returns this. Why? Because this representation indicates that the second row of A, and the third column of A, What is the intersection point? Intersection point is the location of this element, which is 6. That's why the MATLAB automatically returns 6. We can make assignments as well. For example, I can use lowercase a equals to A, let's say 3/2 this time, and 3/2 element is that one, 8. It is just equal to 8, and in this representation, MATLAB automatically will get that element and assign it to some other variable, let's say a. A is equal to 8 now, as you see. Let me clean the screen. Here in the memory, we have lowercase a, capital A. Capital A is a matrix. Lowercase a is equal to 8. Arbitrary index, not arbitrary index, the index, the element, we have just given the locations of it, okay? This example shows that one. Maybe I can just show you here. C21, row number 2, column number 1. It is 3, as you see. C32, row number 3, column number 2, 0. C51 reports an error because it consists of only 4 rows. There is no 5th row. That's why it cannot reach that element. It will report an error here. Also, if we use only one index, what happens? Okay, matrix-wise entries are represented by two index, but what happens if we use just 2? MATLAB executes them, but how? For matrix entries, I mean, for conversion of matrix entries into vectors, MATLAB automatically makes a column-wise concatenation. And after column-wise concatenation, index of this one is 1, index 2 is 3, index 3 is 3, index 4, index 5, index 6, 7, 8, 9, 10, 11, and 12. Okay, that's why C2 reports this element, because if you use only one index, MATLAB considers the entry as a vector. Because it's a matrix, it automatically concatenates the columns of the matrix and reports you the element. But for matrix style entries, I recommend you to use double index entrance. I mean, the first index represents the row number, the second index represents the column number. By this way, you will have no errors. By the way, for C13, you will get an error because there are only 12 elements in representation of C. There is no 13th element. It will report an error. Let's see how many elements there exist after the break, of course. Do you have any question by now? It's time to have a break. Before, let me give the break. Let me download the attendance list. If you have any questions, you can ask during this time. I have downloaded the attendance list. No questions, I think. Okay, I stop recording, and after the 15 minutes break, we can continue. See you 15 minutes after.